I'm Anil Kumar and we'll discuss slope, rate of change, and we'll investigate cubic function in this particular video in greater extent. The question here is, does the function f of x equals to x cube ever have a negative slope? If so, where? Give reasons for your answer, right? So I'd like you to pause the video, answer this question. It could be answered in many different ways. And I'll approach it in very, very different ways, right? So I'm not taking a approach which is I should say the perfect approach, but I'm kind of giving you different options which can help you investigate, think, and answer this question. Okay, so I'm avoiding the perfect answer. However, I'm exposing you to different ideas. Okay, that's the whole idea of this video. So let's read this question once again. It says, does the function f of x equals to x cube ever have a negative slope? That means it could have a slope which is positive, which is 0, but you have to find, can it have negative slope? Okay, if so, where? Give reasons for your answer. So let's first sketch the function. Cubic function we know is kind of like this, right? So I'm making kind of an enlarged version, which is enlarged near the origin, right? So it's kind of like this. If you look at this function and draw a tangent line at any point, what do you observe? So here you see it is positive. As you move towards the origin, it becomes less positive. That means the slope is decreasing. Well, when you are at the center, it is a horizontal line, so it becomes 0 at the origin, right? The slope of the tangent line. But as you move past origin, it again becomes positive. Do you see that? And more positive as you move along the positive direction of x-axis. So as the x values increases, we see that it is further more positive, right? So all throughout we find that the slope is indeed positive or 0, right? So it is, slope is non-negative, I should say, non-negative, right? So that answers our question in a way, and that is kind of a graphical approach in which we could answer this particular question, right? We could actually draw a graph for this kind of a tangent. So if you can work out some values, you'll see the graph of the function is kind of like this, right? So something like this, where it is very high positive value as x approaches negative infinity. It is 0 at x equals to 0 and increases to more and more positive as you approach a larger and larger value of x. So that could be the slope diagram. Okay, so this is, I'm saying, slope at any point on the function which we have considered as x cube. So that gives you a fairly good idea about what we are talking. So, and also answers your question. Now we have also learned how to find slope using difference quotient method. So we'll use that one now to prove what really the value is. Okay. So the difference quotient method says that the slope is the limiting value when let's say h will take 2 points, one at x and the other one as very close, any general point. So of let me say point is a, any point on the curve, a plus h slightly away, minus f of a divided by a plus h minus a, which let me write a plus h minus a, and then we'll again write this in simplified form as we normally do. So we'll have f of a plus h minus f of a over h. So that gives you the limiting value of the slope of a secant, and as you approach 0 it becomes slope of a tangent, right? So that is the concept we learned. Now we will substitute a in our function. So we have f of a plus h means a plus h whole cube, our function is x cube, right, minus a cube divided by h, right? Now we could expand this. You remember a cube minus b cube formula, right? Okay, let me write down the formula and then expand it using the formula itself. I'll write down the formulas here. A cube minus b cube is a minus b times a square plus ab plus b square, right? So we can expand it. Okay, so let us expand it what do we get? So once we expand, we can expand here itself, and then we can discuss. Limit h approaches 0. So a minus b means a plus h minus a times a square, which is a plus h whole square, right? Plus ab means you multiply these two. So plus a times a plus h, plus b square means a square, right? So a square, right? So all this divided by h. So that becomes the kind of expanded form, and we can now simplify this a bit, right? So, well, you could do like this also, but I think, we'll just expand a plus h whole cube and simplify rather than factor and figure it out. You could factor this as h, a plus h. Okay, now that is what we get, right? So anyway, we could actually simplify this also, but I think it's easier to expand and do. We know a plus b whole cube is what? Let me use that formula now. A plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. So we'll use this formula, right? So forget about this. So when we expand it, we get a cube plus 3a square h plus 3ah square plus h cube. So this is expansion of a plus h whole cube minus a cube. Okay. This method is good, provided we know the value of a. It becomes simpler, but this time I know it is going to be lengthier, so I'm aborting that particular approach, right? So it is a good decision to take. Okay, so you should take such decisions in your test paper also. Now a cube minus a cube is 0. So we are left with these three terms, and in each term you find h as a common factor, right? So I'll factor out h. So I have factored out h. I'm left with 3a square plus 3a h plus h square. Perfect. You observe that a cube minus a cube is 0, right? So I'm just crossing it out to make it absolutely clear what we did at this stage. Over h. Now h over h, that could be simplified, right? And then we can write this as limit h approaches 0. And what do we have? We have 3a square plus 3ah plus h square. Now here we can substitute h equals to 0. So these terms will become 0. And what we get is 3a square, where a is any point on the graph of the function x value, right? Any x value. Now you can see from here very clearly that a square is always positive. So that is the slope, right? So it's a slope m. So what we get is slope is this. So we know a square is always, I should say, non-negative. It could be 0, right? It's always non-negative, right? And that means that slope m, which is the slope at any point, x equals to a is non-negative, right? So is non-negative. Okay, so that is how you algebraically prove with the help of difference quotient method that it is non-negative, right? So what we discussed here is, from the graph it is very apparent that the slope is not negative. It moves from a very large positive value to 0 to negative value, up to another positive value, never negative. And then we use the difference quotient definition of slope and proved that it is 3a square in fact, and a square is always positive. Square of any number will be positive, and 3 times that is also, non-negative. It could be 0. It is 0 when a is equals to 0. Perfect. And we did apply, there are 2 different ways to go about for this different quotient. We aborted this method, right? Since we thought it will take longer time. This is, however, a good method to be used when we're working with a specific point, right? So in such case, I'd like you to follow these steps which we did to get the result. I hope that helps. Thank you. and all the best.